We would like to welcome to the stage John Blackford. He's going to be talking about USP, and he's with Vantiva. So thank you, John.
Thank you. All right. As you mentioned, I'm going to be talking about USP. So a little bit of background on myself here. John Blackford, I'm an engineering fellow at Vantiva. And I wear several different hats from a Broadband Forum and Purple Foundation perspective. At Broadband Forum, I am one of the work area directors for the Broadband User Services work area, that's the work area that does everything around USP and previously TR69, the TR181 data model. I'm also a project leader for the OBUSPA project, which is the open source project that created the USP agent that we're now embedding inside of Purple OS. I'm also on the board of directors for Broadband Forum, and I serve as the chairman of the board. And then on the Purple Foundation side of things, I am a community board member, so I'm also kind of on the board of directors for Purple Foundation as well. So let's talk about USP services architecture. First off, I wanted to kind of look at some industry trends that we're seeing, and some of these are probably not shocking for the people in this room because this is what we're working on and what we're building. But one of the industry trends that we're seeing from a vendor perspective is a move away from proprietary stacks and a move towards our open source device stacks like Purple OS. Doing this gives us some cost effectiveness, some benefits from a community-driven approach to creating the software, as well as some freedom for the service providers to kind of pick their own management of their devices. We're also seeing a change from monolithic device software to more modularized device software, which includes some, not just services and microservices on the device, but the ability to have containerized applications deployed on the device as well in order to provide some value-added services that the service provider can then offer their customers. And if we look at things from industry trends from more of a service provider perspective, what we see on the far left here is kind of where we started at before Purple OS started coming into the picture. Basically, service providers were sitting up at the top. They didn't have much choice. The CP vendor had all the choice in hardware and what kind of monolithic device software they were going to put on that device. And it was difficult to get applications onto that device as well. It would take specific engineering efforts for every single device. We started trying to move towards the right here, where now the service providers have a little bit of an easier approach to figuring out what which containerized applications they want to put on the device. But the CP vendor still kind of has that choice of what hardware to use and which open source stack to use. And then the goal is to get toward the area on the right-hand side here where we have the service providers actually picking, I want to use Purple OS or I want to use RDK. And I want to put these applications on top, and then they have a choice from different vendor hardware. And so that's kind of the direction we're heading towards. So how does this really fit in with USP? Well, Purple Foundation, a lot of the joint members between Broadband Forum and Purple Foundation came into Broadband Forum in 2020 and said, I love what you're doing here with USP from an external service perspective. A standardized way of having external services being able to communicate into that device with the TR181 data model so you know exactly what's there. But what we want you to do is we want you to extend that internally to the device as well. So we want USP to be able to communicate internally in the device and now have standardized services inside the device as well as outside the device. So Broadband Forum said, yeah, okay, we can do that. So Broadband Forum went to work, and let me build out the image over here. Went to work and went to creating some extensions for the TR181 data model, extensions for the USP protocol itself, defined a new message transfer protocol that could be used internally to the device, would be a lot more efficient, and picked a Unix domain socket approach to do that. And then also created, took the existing concepts of a controller and an agent and kind of built those out to a broker and a service. So essentially what would have been seen as the agent on the device, the one USP agent on the device, is now expanded into a USP broker. So it still has its agent that's there for external communications to any USP controller that might be located in the cloud or outside of the actual device itself. But that broker now has a embedded controller in it as well. So that controller can now talk internally to any USP services that exist inside the device. So a USP service will have its own data model portion, and it will have an agent on it that exposes that data model to the USP broker. A USP service could also have a controller embedded in it. So that gives a lot of flexibility here. A USP service with only an agent would be what we might call a data model provider. It's hosting its own little portion of the data model and giving that up to the USP broker for inclusion in the larger device's data model. Whereas a USP service that has both an agent and a controller is acting as both a data model provider and a data model consumer. It can now go and ask the rest of the system about data model paths that it needs to get its function complete. So that's more of the theoretical side from Broadband Forum. We also have more of the integration approach from a prpl perspective here. So in prpl we have existing services that have been there for a while, and these are UBus services, or basically Ambiorc services, as we just kind of heard in the last session. With the Ambiorc service, you also have the ability to do bus abstraction. And so an Ambiorc service can be changed between a UBus communications path and then a USP UDS path. And so we can have like native USP services that talk USP UDS internally to the device, but we can also have services that talk UBus internal to the device. And so that gives you kind of a hybrid approach inside the device, and depending on which communications path you want the device to communicate with. So that provides a need for a bridge functionality, something that can span the worlds of UBus communications and USP communications. So that bridge is basically an enhanced version of a service that was already on as part of prpl, which is the TR-181 device service. So working as a group, prpl has come together and we've enhanced that service such that it can now handle USP messages coming into it for any portion of the data model that is actually being served by UBus. And we'll get back to this towards the end of my presentation, as I'm going to show you how this actually works in real practice against a real device. So let's build out a little bit of the concept here. So typically what you start with is you see a USP agent on the device. That USP agent talks to a USP controller, most likely in the cloud. There's a data model associated with it. That USP agent has the ability to communicate down with the rest of the native platform for routing, Ethernet, whatever. But what we add here is the ability to also bring in a dynamic portion of that data model. And so this third-party app here is an example of a USP service that is built into the actual firmware and then has a communications path back to the TR-369 agent, the USP agent, such that whatever data model it is exposing is now exposed as that app one portion of the data model to the outside world. And so by introducing new applications, you can dynamically adapt your actual data model of your device. So the next step here is introducing the concept of what we don't want to build that application into the firmware itself, but we want it to be more containerized and more dynamic than that. So that's where prpl LCM comes in as one of the pathways to help us get to that. prpl LCM is the software module management aspect that takes care of all of the containerization concepts, gives you the ability to do an install of a deployment unit or a piece of software, a containerized application, update it, uninstall it, configure it, all of those aspects. And so with the introduction of Purple LCM, you now have the ability to bring in a third-party app that is a containerized app. And this third-party app can also expose its own portion of the data model. So just because you install a container now via Purple LCM, you've now enhanced the data model and the capabilities and the functionality of that device. And you can keep going. You can add more and more. These containerized applications can also have cloud components to them. But it's also going to be exposed via the USP path and that remote management path as well. All right. So to get over to our demonstration, I'm going to set the stage a little bit so that you know what we're talking about here. So I'm going to refresh your memory and bring this page back. Kind of the most important part that I want to let you know about here is that bridge concept, what's bridging between the USP world and the UBus world. So that's what we're going to be exercising in the demo. And to give you another look at this, we built this little image out here that shows the different paths. And so top left there, you have your USP controller that's talking into your agent, the USP agent. And so we're going to do a few different things. We're going to show you some paths where we retrieve data model components from that actual USP agent, so portions of the data model that are kind of it's responsible for. And then I'm going to show you a third-party app that's on the device. That third-party app is a USP service. So you'll see communications going back and forth between the USP agent and that third-party app. And then we're going to go and we're going to pull up some data model components from the UBus service side of things. And in that case, what will happen is the USP controller will send a message to the agent. That USP agent sends a message to the TR-181 device service, which then converts that message from USP over to UBus and sends it across UBus over to the TR-181 UBus service. And then the path back has that data coming all the way back and up to the USP controller. All right. So let's jump over to the demo here. Just refresh my browser. All right. OK. Yep, I see we have the screen up. So we have a couple devices here that are active and online. What I'm going to be using is this GLI-Net device here. This GLI-Net device has the same firmware that we're running on this device over here in front of us. Same exact build. We're just using this one here. And so what I'm going to do is I'm going to come over to our area where we run commands against the actual device. And I have a bunch of paths, so you don't have to watch me type over here. So I'm going to copy our first one that we're going to do is just a quick check to see how many different MTPs we have on the device. Now, MTP is message transfer protocol. So this is the MTP on a local agent. So this is basically the portion of the data model that says the local agent, the USP agent on the device has this many abilities to communicate. And so we look at that. We have 2 of them there. Okay. So let's do a little bit more investigation into what's under there. So we'll put in this path here, which is in one other path. We're also going to get the protocol. All right. So we're going to get 2 things. We're going to get the enable parameter and the protocol for all the different MTP instances. So we're using a wildcard search here to retrieve all instances. So we run that. We see that we have 2 of them. We have one that is, they're both enabled. One's using Stomp as a protocol. This is one of the protocols that USP has defined. It's more intended for like external communications. If you look at all the different USP message transfer protocols, Stomp and MQTT are kind of similar in nature. We're using Stomp in this demo. The second one you'll see is also enabled, but it's the UDS. So this is the new MTP that that broadband form added specifically for this purpose. So this is the internal communications. So we see that this USP agent can both talk external and internal. All right, so next up, I'm going to go ahead and get about the controller. Copy that. All right, so what I'm going to get now is the number of controllers that this local agent has. So basically the number of servers that it's talking to, essentially. So we see that there are 2 of them. Okay, so let's get a little bit more detail on these 2. We're gonna get the enable parameter again for the controller side. And we're gonna get the endpoint ID, which is the unique identifier for that controller. Sorry. And then we're going to get the protocol as well. So we want to see what these different controllers are actually talking. All right, so let's run that. Okay, so out of those 2, we see one of them has an endpoint of dev endpoint, and it is the stomp. So we have a stomp controller, USB controller, which is the actual one that I'm using to communicate with the device right now. And we also have another controller down here that is the Proto TR181 device. This is the bridge that I was talking about earlier. So this is the actual TR181 device service that is going to be communicating between USP and UBus inside the system. And we'll get to that a little bit later in the demo. And we'll see he's communicating via UDS. All right, so just a couple more things. I want to show the UDS side of things. So we have some data model components here. If we look at all right, so this is going to show us what this actual local agent controller has from a USP UDS perspective. So we see that it has 2 things in here. It's got a USP service reference as well as a Unix domain socket reference. So this is saying that as that bridge component is a USP service itself, and this portion of the data model is where he has all of this other details about the USP service. And then it's also showing that it's using Unix domain socket.2 as the connection point. So let's now look at all of the USP services, not just that one, but let's see if there's more than one out there. Okay. So here we have a little bit more data that we have in here. We see that we have this first one and all the data model paths that is exposed. So this is the bridge that we talked about before. And so we see that that bridge is bringing across all of these different concepts from UBus, and it has exposed or registered all of them to the USP agent, which means that the USP agent will now be able to use the bridge to get to those portions of the data model. So later on, I'm going to do some queries into the host table, which you'll see has been registered as part of that right there. All right, so we also have a second USP service here. This one, as you can see, is the device of Vantiva USP app service. It is using UDS, and you'll also notice something else here. The first USP service has a controller, whereas the second one doesn't. So the second one is really just a data model provider. It doesn't have an embedded controller itself, whereas the TR181 device service does have an embedded controller, so it can also make queries into the USP side of things. All right, so next up, I'm going to show you a little bit of that USP service. So we'll see, first I just want to show you a general view of what the data model is for this USP service. All right, So here we see it's a very simple service. It has one parameter, the result. And what this service is it's an application that's kind of a calculator. So there is an operation that we can run on it. So there's this calculate command here. And so what I can do is I can switch over to our operate function, put our command in, we'll send a response, and then we want sum is our path, and whoops. And for our calculation, we'll just do something simple like this. And we'll run that. And so we see it comes back, and its value is 60, so it did the math right. We can go back to the get, and we can show that path again. All right, run that. Oops, forgot to hit enter. There we go. Run that. And so we see the values there as well. So that's just showing how we got a USP controller talking to the USP agent, talking internally USP over to a service. So now the fun stuff, let's go look at communicating across the bridge and actually getting some U-bus paths. So the first thing I want to do is just show you that we have some host table entries here. We have 70 host table entries. There's probably not going to be all active, so let's just do a quick look and see how many are active. All right. We return that. So we see we definitely have a couple of ones up top that are active. There's definitely at least a few of those 70 host entries that are active, and maybe at least 6. But what I also just showed was a wildcard search that went from USP across to the tier 181 device and into U-bus. So this is a USP concept as well as I think a U-bus concept. So, but it's just kind of showing that those same concepts can span both sides here. The next thing we'll do is an actual query here that has a search path. So in USP, a concept was added to USP that was called search paths. So what it does is gives you the ability to put kind of an expression inside your get path that allows you to only get a portion of the data model. In this case, I want to just get a portion of the data model that has the active parameter as set as true. So I don't want to worry about those 60 plus devices that are not active. And so I run that one. And here we see that search path went across USP into U-bus, and we retrieve the data back. And so we have a number of devices here that we've got. That's interesting, but that's still a lot of data. So let's filter it down and just show the host names. Copy that path over, paste that, run that workflow. And now we have just the 6 or so, six host entries that have that are active and just showing their host names here. And that is the end of my demo. Thank you all.